what you know, what you can see. One of the things we talked about was what we call that reflexive side. Reflexive sides are sides in triangles that are shared. Hey, Judah! Are sides that are shared, sides that are overlapped. You know right away that you can mark that. Now what do you have?
Side, side, side.
Ah, do you see his third side?
No, side, angle, side. That's what I meant to say.
Good. Same thing on 3. What's shared? See how that shared diagonal? It shows up over and over and over again. This is your side, side, side.
Yeah, I was looking at the.
That's really gross. Sorry about that.
What?
So, one of the things that we're going to do today is, you know how we filled in that pseudo part of the progression about the reflexive stuff? I'm going to show you how we write that into a proof today, because we will be using that a lot from now on. In 4, again, you have this shared side. Is it congruent to itself? Yep. What do you have?
Side, angle, side.
There you go. In 5, can you do anything?
No.
Nope. Don't have enough information. There's nothing here that I can do. No. In 6, again, you have a shared side. If I go through and I see I have AC as a shared side, okay, cool. Now watch what you have. You have an angle, a side, and then a side. Is there an ass in math? No. Yes, ma'am. It does not work. Angle, side, side does not work. It's not a thing. Okay?
Can you re-explain that one?
Sure. In this one here, when you look at the actual diagram, you go through your tick marks. Go in the order in which you have things written. Right off the bat, object, that's why. Right away as you look at this is annoying. You've got an angle. When all else fails, hit the chew button. You have an angle here, an angle. All right, so right now we have an angle and we have a side. When I'm looking at my possible ways, having an angle and a side means I'm either going to be side, angle, or angle, angle, side. So I have to decide what other things can I find. Well, I have a reflexive side, AC. This tells me now that I have an angle, a side, then a side. Is there an angle, side, side in math? No. Because there's no ass in math. Okay? That's why it doesn't work. You have to follow your lettering. It's not side, angle, side because the angle would have to be between the two sides. In this case, it was not. Okay? That's why. Now, if it was this angle here, in this one, then you'd be okay. But since it's not, it won't work. Okay? That's why. On your progression sheets, I asked you guys to always look for a certain type of angle. And it happens to be when you see things that look like bow ties. The point at which those two triangles meet create angles, don't they? What kind of angles?
Vertical.
Vertical angles. And what do you know about vertical angles? They equal each other. They're congruent. On your progression sheet, you should have something on there. Vertical angles are congruent. I can take that from a diagram, and now what do I have for 7? I have two sides and the angle between them.
Side, angle, side.
There you go.
Same with the next one.
Same markings, but look what you get. Side, side, angle. Is there an ass in math?
No.
Nope.
Yeah, I didn't know that we were allowed to cross them out, so I just kind of like made up stuff.
Yeah, I think on the instructions it tells you sometimes some are not possible.
I did.
Oh, you could write no congruence.
Or just say no.
Oh, I didn't do that one.
And this one here, you've got two angles. How many degrees are in a triangle? Take 60 and 61, what are you left with? 59. Do the same thing at the other triangle. Oh, look at that, 60 and 59, what are you left with? 61, so you've got 61, 61, 59, 59. So you have two angles. Do you have a side between them or a side after them?
After.
In between them, because you've got that reflexive side again. It's angle side angle. It's angle side angle. This next one is the one where most people will start to see a pattern. Whenever you have two parallel lines cut by a transversal, you get alternate interior angles congruent. But in this problem, you have two sets of parallel lines, which means you have two sets of alternate interior angles. So you have two angles. So if I have two angles, I'm either going to have a side between them or a side after them. What do you have?
Side between it.
So it is
Side. I mean,
There you go.
angles.
angle side angle. I'm going to give you a hint here, guys. Anytime you see something that looks like a parallelogram and the sides opposite are both parallel, that diagonal creates alternate interior angles going both ways. If both sets are parallel. It happens every time. Okay? 11 we did in class, it's the flag pennant one. The pennant one, it should always give you corresponding angles, and you get angle side angle. But then on 12, notice in 12 you've got the bow tie problem again. So you have sets of not parallel angles, you have sets of vertical angles here and here. And you also have your parallel lines. Oops. We have our parallel lines with transversals. Alternate interior here. Alternate interior here. Is there such a thing as angle, angle, angle? Nope. That's another no. Those two triangles will wind up being what we call similar in a couple of weeks, but for right now, you cannot say that they are congruent. Because angle, angle, angle isn't up on the board. There's only 5 ways to show that triangles are congruent. And if what you come up with isn't one of them, you're wrong. Not to be a Debbie Downer, but you're wrong. And the last row. Here's another hint. Whenever you have what looks like a parallelogram and you only have one set of parallel lines, you're only going to have one set of alternate interior angles. Those. Okay. And then again, obviously I've got this reflexive side. Stay off your phone, please. And when I have the reflexive side, now I can go through and look at what parts I have. The triangle FAC, I have a side, the angle, and then the side. So this triangle shows side, angle, side. The other one I have side, side, and an angle. Are those two going to be the same? No. Their tick marks don't match up. There's no way of writing them that they're going to work because the angle isn't between on both pairs. You can have congruent sides, you can have this one congruent angle, but we have no idea what this angle is to make it work. So this one is another no. Not congruent. Okay. Set of parallel lines, what do you think you're going to wind up with when you have an enclosed figure? Alternate interior again. Is there a shared side? What do you get? What's that? How many angles do you see? Only one angle, there's two sides. You can't say anything about the angles here and here because the other sides aren't parallel, okay? So you can't say anything about those other two. So you're not going to have angle side angle to show on this one. And then the last one, you're given the two sides. You've got two right angles, but what else can you mark? The verticals. Yeah, you got the verticals. So what do you wind up with? Follow it. What do you have? It's the side between the angles.
I did siding and side, but I don't know if that's right.
How many sides do you see? One. So you know it's not going to be this or this. It's going to be one of these two. Are the angles is the side between the angles or is the side after it? There it is. That's why you have to write these things out. That's why you got to look at them to make sure you know where your things are going, guys. That's how this stuff works. There's no trick to it. There really isn't. Look at the diagram and look at where your stuff is placed. Pick a spot, right angle, vertical angle, side. Angle, angle, side. You're going in order. You don't jump around. Just because there's two angles on the side doesn't make it angle, side, angle. Because the side would have to be between them. It's not. When you start to get into what you did yesterday, you have to be looking at what's your given statements. And this is kind of what we're going to build out of today. Today, yesterday what I had you guys doing was basically marking your diagrams yourselves, using your progression sheets, knowing what a midpoint does, so that way you can mark your diagram to look like what it did 2 days ago, to know whether it's going to be one of the 5 alphabet soups. So, oh, wait a second. Do you see anywhere in here that says it's perpendicular? Do you see anything in here that says there's right angles? Does anybody see in the given anything that talks about perpendicular or right angles? You look really, really close. Do you see anything that says anything about perpendicular right angles?
No.
So are there perpendicular right angles in number 3?
No.
So should you have used them?
No.
You cannot assume anything because is there an angle side in math? But what you can do is the following. You know that you have a midpoint. On your progression sheet, what does it say to do about a midpoint? Look at it. Don't look at me. Look at your sheet. You're going to have to be able to use these sheets, guys. Otherwise, I'll take them away from you. You'll have to memorize them. So look at your sheet. What does a midpoint do? Segment equals segment. What are the two segments? Well, D is the midpoint of AC. There you go. I've utilized it. Why did I mark my diagram? Because I just used the definition of a done. Go to the next given. What does it say? AB is congruent to BC. Okay, I mark it. As of right now, I have a side, which means I need to find another side or an angle in between them. What do I have? A side. Why can I mark DB? Not bisector. Why can I mark DB?
Isn't it like reflexive?
Reflexive. I swear I thought you said symmetric. Bisect. You guys said somebody said bisect. I swear I heard someone say bisect.
Me too. I said
Okay, if you guys said reflexive, correct. I thought you said bisected.
I think someone did. I don't know.
No, reflexive is correct. I swear I heard someone say bisected.
I did too.
So that means you wind up with side. Guys, you cannot assume that you have right angles. You cannot assume anything. You have to take it quite literally from the given statements. And that's the point. Being able to look at what's given to you, use those definitions from your progression sheet, and then remark the diagram. That's how these things work. That's the whole point of all that work we've done for the past month or so of filling these things in so that way we can get to this point. Okay? You have parallel lines. These are parallel according to my progression sheet. According to my progression sheet, if I have parallel lines, then I need to look for some angle pair relationship. Well, I'm looking through here. I have parallel lines. I'm redrawing my parallel lines to help myself find them. I have a diagonal. Hey, look at that. Alternate interior angles. I know those two are congruent, okay? I go to my next thing. A is a right angle, okay? C is a right angle. So according to my diagram right now, I have two consecutive angles that are the same. Which means I look at my possibilities, it narrows it down to these two. Do I have a side between them or a side after them? What is it? It's after. Because you've got the diagonal. Follow it. Angle, angle, reflexive side. You guys have to be able to mark the diagrams and follow letters. That's all I'm asking you to do. You have to be able to look at angles and tick marks and follow letters. That's all this is. All the answers about how you mark your diagrams are on your progression sheets. It's a matter of reading a definition. Yes, ma'am?
So when you have the line in the middle, how are you going to know if you have the two angles that you drew on? Like the...
Good question. What happens here, if you go back and let's say you're trying to think maybe these would be the same. In order for this side to be the same, wouldn't that angle have to come all the way back to here?
Yeah.
It doesn't go all the way back up there because it's blocked. So that's why we always look at the one that comes through here. It's these on the insides.
Like always?
When they're drawn like this, if you want to think about the side that's parallel, it comes up and goes. Now, the other diagram we had a second ago, I think was rectangle, and it went like this. So again, what you're looking at is you came to here, down and over, and then it was these. Okay, does that make sense?
A little bit.
Because if you go this way, it doesn't come all the way back up to that line.
Okay.
Because your line is going to create the angle.
So like make a Z basically?
Yeah,
Okay.
it's kind of the easiest way to do it. But then if you go this, but then sometimes we had them that did this way, and then that's when you're able to get both of them. But if you have one set, it's just make your Z to follow the lines through, and it shows you which way it's going to go. Yes, ma'am? Yeah, go ahead. Same deal here. I'm looking at my diagram. I have a given statement of midpoints. Midpoint was the very first thing we ever put on a progression sheet because it's easy. If you have a midpoint, it creates two congruent segments. So just look at the diagram and mark them. We know that P is the midpoint of AB, or AD, excuse me. I know that. If you're not marking your diagrams, you're just setting yourself up not to do these well. You've got to mark them, guys. And I do the same thing with BC. So right now you have two sides. Can you find that third side, or can you find an angle in between them?
The vertical angles.
Very good. And that's the thing. We've got the bow tie looking, vertical angles, side angle, side. Because on your progression sheet, there's a square that says, look for vertical angles. What do you know about vertical angles? Well, it would be angle equals or congruent to angle. Why? Vertical angles congruent. Done. That's how this works. It's much, much easier to do these than it is all those segment addition and segment angle addition problems. These are much cleaner because there's an end in sight. It's very, very straightforward. Angle bisector. What does an angle bisector do? It bisects what? An angle. So you create how many different angles then? Two of them. So if AD bisects BAC, that means you get these two angles. Just by the definition of an angle bisector. Why do I know that? Because my progression sheet said so. It's kind of boils back to that whole piece of paper, doesn't it? Yes, ma'am.
I think why I got confused with that is because it says state that angle equals angle, but then it already said angle B is congruent to angle C. So I
But
think
it's
I got
this is the
confused
second
by
given.
that. Yeah.
Did it with a comma.
Yeah.
And then you have these. So again, you've got two consecutive angles. Do you have a side after them or a side between them?
Between. Isn't the.
Well, the side between would be here or here.
Oh no, I was
It would
doing
be-
the middle one.
Yeah, it'd have to be after one, yeah. Because if it was between them, it would be angle, side, angle. But since it's angle, then an angle, then the side.
Yeah, I think I put middle because of the reflexive thing that
Yeah.
we keep doing.
You're not wrong with the reflexive. So if you, let's say you did this in a proof and you did everything right, and you got your whole bisector, you did your angles, you did your last givens, then you said reflexive 80, triangles congruent, but you actually did angle, side, angle. Everything else is right except for that last bit.
Okay.
So you didn't do anything else wrong. So just be careful and make sure you write out. I'm hoping you guys, one second. I'm hoping you guys are seeing why I'm writing these two letters out first. Then I'm asking, where does the last one play into? That's the easiest way to do these things. Yes, ma'am.
So you know how it says AD bisected?
Yeah.
Does that mean that, like AD or ED and DC are the same?
No, it's bisected at an angle. If it was bisecting the side, you're right. Yes, ma'am.
Because you know how like you mark the angles at the top because they were the same because
Yeah.
it was bisected? Wouldn't you also mark the ones at the bottom that were the same?
Can't. It doesn't say it bisects that bottom. Because here's what can happen. Okay. If these two base angles are the same, what kind of a triangle is this?
Isosceles.
Isosceles, very good. This becomes an isosceles triangle. If you happen to have an isosceles triangle, and this is what we call the altitude of it, it is the perpendicular bisector of the side. But later on, we can have an angle bisector that does not bisect the bottom. Depends upon how the triangle is drawn. Okay? And we do that in 5. Okay? I forgot what that was called, but it's something. And there's things that we can do with that later. And there's no proof to it, so you'll be happy. We only have like a week left of proofs, guys, really. We'll be done with this. I'm thinking we should be done with this by next week. I really do.
So does that mean test?
Yeah, I think we should be able to be done with this by the end of next week, if not the Tuesday before break. Because I don't want to do a Monday test, because that's awful. So, okay, but we don't have much left. We're further ahead than I thought we would be with these things. Last one. We have an angle bisector twice. I have an angle bisector twice. So I have these two angles congruent, and I have these two angles congruent. Which means I have two consecutive angles. Which means I need to find a side between them or a side after them. What do you have? Reflexive again, very good. You've got it between, so you wind up with
Angle side angle.
the tips on these things are getting flattened out so it looks like it's gravity. That's all that is, guys.
No, this one says that.
The last one I'm not really worrying too much about. I forgot that they talk about a square. I'm not going to give you stuff that we haven't defined yet. Believe it or not, I know you guys know what a square is, but you have to do a lot of definitions here. I won't make you guys do a proof of this on your own. This is too much work. We know that all 4 sides are the same, and we know we have angles the same. You have side angle side right away, or you might have recognized you had a reflexive, you would have had side, side, side. Or you would have had a reflexive in a leg, you would have had hypotenuse leg. Or if then you could have also done the whole, if you knew about triangles or squares, you would know there would have been the angles are bisected. There's a whole bunch of stuff here. I won't give you a proof that just says, hey, this is a square. Too much work. Okay? So let's take out your progression sheet real quick. I want to fix that last little bit that's in there with reflexive.
Are we not turning these in?
No, because you're going to use them today. We had this in there the other day. We had something in there the other day about look for that reflexive, quote unquote, shared side. And I think we had a diagram.
But you were saying share.
We had something like that where we would just put a little tick mark on it, I believe. Now, here's how you would utilize that within a proof. This is what you would write down. If this was a given, or if this, remember, reflexive stuff would not be given to you. It's just like a vertical angle. It's something that you can interpret from a diagram. It's one of those allowable things. If you wanted to say that AC is reflexive, all you have to do is the following step. AC, congruent, AC, and the reason? Reflexive. And that's it. That's how you say that it's there. Yes, ma'am?
That's where we have to, like, when we were doing the, I think maybe angles, where you had to state that the middle was there.
Exactly right. That's why you had to do it. Okay? And we actually can do that later on because there are, I don't know if we'll get to it this year, or I don't know if we'll see it. There are shared angles, there are reflexive angles that just they don't show up very often though. You could have an angle that's overlapped. It's just very difficult to draw those pictures and diagrams. So that's really what we're going to use. So anytime you see a diagram that has that overlap stuff, you can automatically say one thing, that one part is congruent to itself because of that property of reflexive. Let me walk you through what we're going to do. Oh no, thank you for being so polite.
Oh, no.
Yes, thank you for reminding me. Please do, guys. Please put those 5 examples in the box. Hey guys, if you want to do something nice, shoot Mr. Gonzalez an email, say hi. He's going to be in the hospital for a while. He's not coming back this school year, but he should be back next. So he's having some health problems. So shoot him an email if you had him before. Say hi, wish him the best, that kind of thing, if you don't mind. Yeah, I think he was around right before he went back to the hospital. Excuse me. Wow. Oh, I actually counted right? Yes. Welcome. So let me show you this. I'm looking at 13 on 4-3. And this is how you attack and go through an actual triangle proof. It is so much easier than what we've been working on because you've done all the other work. Everything that you need to know, you have on your progression sheets. Every bit of information. Well, that didn't work at all. So as I go through this, you are given AB is congruent to CD. So, G, I'm going to mark the diagram. Why do you think you wrote down AB is congruent to CD? Because it was given. Don't ever write anything down here until you've marked your diagram first. Always mark your diagram before you write down a reason. Okay? Always mark your diagram before you write a reason. You've used that first given. Secondly, BC and AD. Okay? I marked my diagram, so now what am I going to write here? Given. Now, in my diagram right now, I have 2 sides in a row, which means I need to find an angle in between them or a third side. What do you think you have? A reflexive side.
I have a quick question.
Yes, ma'am.
Which one are you?
13 on the.
Yeah,
on the.
no, you were on 17.
Oh, yeah, those look similar.
Yeah.
I have 13 because I can say that. Oh, look at that. AC is congruent to AC. Why are you congruent to yourself? Because you use reflexive. Told you they're easy. We did all the hard stuff. Why are those two triangles congruent? What do you have? Two sides, and then we found the third side. Done. That's all. No, yeah, absolutely. What's up? You don't write anything else beside, you don't, all you do is write down what I write down because there's no reason to write out the full words. Yes, sir.
What would be number 3 on the course?
Well, if you're given a midpoint, what does your progression sheet tell you to do? If you're given a midpoint, it tells you to do what about your segments? Look at your progression sheet. If you're given a midpoint, what does it tell you to do? Segment congruent to segment. So if I mark by diagram where a segment is congruent to a segment, hey, didn't you just mark down AD is congruent to CD? Why are those two congruent? What definition did you just use? There you go, man. That's it. That's how it flows. It flows right out of that. You're using the definitions to mark the diagrams, just like you did yesterday, but now you're doing is writing down what you did. Yeah. Yes, ma'am. Yeah. Stable. What do you think? What is midpoint do? What is midpoint? What is it?
Alright, so this is here, this segment here.
Always mark the diagram. What's up? You are yourself. You just filled it in on here too. Oh, you did. Oh yeah, there it is. Sorry, I apologize. I don't know anything. You can't make up stuff either.
I seriously don't know. And
Wait, what do you mean by disabled?
Oh, thank you. Hey, yeah, real fast, there's a weird symbol that they've used for an angle. Just so you know, when you see this, isn't there like a slash in that? This is the same thing as this. I don't know why it did that. Don't worry about that number 15 on the bottom, that first one where it says picture frames. I could care less about stability of a picture frame. It doesn't matter to me at all. Yeah. I'm never going to ask you anything about them. I just want you to do the 3 fill-in-the-blank proofs, and one of them is already done, or excuse me, 4 of them, and one of them is already done. And you probably have most of the second one done as well. Yes, ma'am.
I've done 12, so I
Yeah, I feel like
11s are easy.
That's the thing. You're doing everything. You do everything marked exactly where you're going. And this is weird. You talked about it twice.
I never learned in third grade. I never knew about that. I've always been bad at math.
Oops, sorry.
So just this one and the 2 on the